We got 4 viewers. That's perfect. We're up to 4 viewers again. Oh, hey guys. So we just had we're in a warehouse here outside of our normal Haas factory, and it has its own internet here. Normally we've got 500 megabytes of internet up and down, and the whole internet thing just died a few minutes ago, and so we're going to try this again. Maybe we'll merge these 2 videos together and repost it in a little bit. So sorry if you were intently watching our discussion on abrasives and we
20
lost
minutes
you.
into abrasive wheel discussion.
They let me talk for like 10 minutes before they let me know, like, we're not on the air. We're not on YouTube. And I finished my coffee break. I got to the caramel at the bottom, and it was pretty darn sweet. We were talking about live tools on lathes. There was a question that came in over the comments, over the chats, and somebody was asking, can they run this wheel in my ST30 with live tooling? And my short answer is no. You don't want to, for a few different reasons. Not that it's not possible, but you don't want a lot of abrasives inside your machine. It's just going to sit there and grind. It's going to go through the coolant system, and it's just going to continue to wear on things. So these aren't grinding machines necessarily, but you can always do that. Plus our live tooling, it maxes out at 6,000 RPMs, which is fine for this wheel. But for a smaller wheel, you'd want more like 10,000 or something. But it's really about that kind of abrasive material hanging out in your machine that we wouldn't like. And besides that, these wheels are ablative. They break down, and that's every time you hit this thing, it breaks down a little bit, exposes more abrasive, and it starts chewing on the material some more. And so that means the wheel is going to get smaller and smaller as you go. And normally on a dedicated grinding machine, they're gonna have dressing in there, so it's going to come in, it's going to redress the wheel. And if you've got a regular, regular grinder, surface grinder, you'll have a little diamond in there, like a real 1 carat diamond on the end of some tool steel that you'll come across and redress the wheel to make it flat again. And then you might have a probe that comes in and measures the diameter of that wheel as things go. So there's machines that are made specifically for that. Generally speaking, if I was going to do any type of deburr work like that inside of a Haas lathe or mill, I would go with a brush, probably. So there's brushes, again, it's a brand, but Osborne brushes is what I call them because Osborne's a brand and they make brushes with abrasives built into them. And you can take those guys, and they're great for castings that have irregular shapes, and so you can't use a chamfer tool because it's just such a weird shape. But you can take that brush, you can touch it off, then bring it down by 1 millimeter, and then it'll have some roughness to there. It'll run across the surface of a part and take out those edges. Really good for when you have lots of channels and it's just too much to deburr. You can hit all those surfaces in one shot. You can even reverse the spindle and hit it the other way so you're not rolling the burr one way and then leaving it there. So brushes are fantastic. You can write macros that brings the brush down by a 0.5 millimeter every so many parts. So there's good ways to deburr inside the machine. In fact,
some of those are maybe is it more applicable to mills, or are you going to sometimes still use that same kind of thing on a lathe?
You're almost always going to use those on mills. There's very few times on a lathe when you need to use a brush. Cross-drilled holes are one of those times when you might want to run through there with something, but they do make, different hones and brushes that can come in there and deburr, different deburr tools. Generally speaking, with a lathe, almost every turned dimension can be hit with a boring bar or an OD tool. So there's no reason to have a burr on a turned part. If you spend enough time programming, you'll be able to get every burr off that part, unless you've got some live tooling, some milling going on, or some cross drilling. Then we might run into problems, that type of thing. And we were just talking about this too. If you've got burrs on your threads, this just came up. We sent out an email last week or a couple weeks ago with inserts for threading. And if you've got burrs on your threads, it's a nasty material and you're rolling the burr one way or another, a lot of guys will come in and they'll turn the OD of their threads again, and then they'll come and they'll hit their threads a second last time to kind of give it a spring pass to knock any burrs off. And that just wastes a lot of time. And I've done it a million times. You're going to hit something twice to get rid of the burr. But you can buy topping inserts, full profile inserts that have the top, bottom sides of the thread profile all in one insert. And so there just isn't a chance for burrs on those threads because it's done with the same tool as opposed to an OD tool and a threading tool. So there's lots of different ways to deburr parts on the lathe. This is not my first, second, or third choice.
Cool. Thanks, those of you that have come back to this news stream. We got Bill from New York, Frank from Connecticut. I'm sorry I can't say your name from the Ukraine. I have no idea how to pronounce that, but thanks for getting back on the stream with us. So, changing gears a little bit, Harindu Gamlath asks, glad you're back. Can an ST10Y do rigid tapping with live tooling on the sub spindle?
Sure. Yeah, absolutely. So you're gonna hold the spindle there. It doesn't have a huge break. On the sub spindle, it's basically a finishing spindle, and so there's not a lot of power there for the braking. We'd have to look it up. The products guys, Milton, could tell us what the braking torque is, how much it'll hold. If you're on center though, absolutely no problem whatsoever. You're going to come with the live tooling just like you would on the main spindle, and you can come in and drill and tap just fine because that's all timed with the live tooling, the synchronization, and not the sub spindle for that. So yeah, absolutely.
We got more people joining us. Turkey, Illinois. Thank you, folks. Vision Forge asks, when are you guys going to start selling BT30 tooling for the drill tap machines? And I don't know the answer to that question.
I don't know, because we were looking at that. I know they were testing a lot of different things. We have so many tools. They've expanded the tooling department for HaasTooling.com by, just they keep expanding. And so they're testing all different types of tools, but that's I don't know.
Yeah.
I know they were looking at it, but I don't know.
No clear time frame on that. And actually that leads into, we had several questions on the last, I can't find them now. Anyway, several questions about when Haas tooling was going to be released both in Europe and then all around the world. We had a question about India and from Qatar, I think. And the plan is to have Haas tooling released in Europe by the end of this year. And actually during the EMO show in October, we have a big Haas tooling presentation space at that show. So that's the reason it's taken this amount of time is it's quite difficult. There's so much involved. It's
not what you think. We have a support for it also, but even just expanding throughout the United States, there's different tax laws in each and every state, and so it's more of an accounting issue than anything else. And so they're getting that all figured out. And
then you run into that as you go into each new country.
Once you cross international borders, it just becomes more and more of that kind of those tax boundaries, and it's all getting taken care of. So eventually, it'll just keep going in that way.
Let's see. So I had another interesting question from last time. Frank Van Niekerk asks, will B-axis tilt probing be available on the UMCs in the future? Setting the datum in a tilted coordinate system. You were saying, we were talking about this a little bit earlier, and you were saying that
there's all kinds of crazy cool stuff coming with the probe. It's a little vague on the UMC. So we've got kind of like tilted work planes. So on our, I'm looking around here looking for the right machine. So we have tilted head machines like our GM25 axis, and we've got these mill turn machines that we're coming out with, right? We've got our VMT 750, and those are tilting head machines. And so the only way you're going to be able to do something at that funny angle is by having these tilted work planes. And so we've got that with our G268, and it is crazy simple on a Haas. You simply say, okay, go to B 30 degrees. You call up your G268, and that's it. You've just called up the plane. You can define it with an IJK, which is a very specific angle around X, Y, and Z. But why? You just move the head to where you want it with this angle, and if it's a 5-axis, you move it this angle, and then you call up your G268, and things just work. So that's there right now. Now, as far as the probing on like funny angles like that, they're doing a lot to make that work right now. It's been in testing for some time. And there's all kinds of little things that are being developed in the software that you might not notice that have to be done before they have that type of probing capability. One of them is if you've got a brand new machine, if you have the latest software on there, you're going to notice that if I call up tool 1 into my spindle, tool 10 into my spindle, and I jog it down on top of my part, then the tip of my tool is going to be like, wait a second, normally it's some random number. It's a machine position. Today, with the latest software, if you jog that thing down, the tip of the tool, it's going to say Z0, because if that's my G54 Z0, it's going to automatically take into account a tool offset number that matches the spindle, the tool in the spindle at that moment. And you're thinking, why was that done? And a little secret, one of the reasons it was done was for the 5-axis probing and other things like that. So we can activate a probe and have it working all the time. So you can just jog up to something and have it probe. And it'll automatically calculate the angle of the head when it's coming in. So all of these pieces in the software are coming together to give us more powerful probing, especially with 5-axis parts. We're gonna have all the kind of information we want, but there are certain things we need to get done first. And what's cool about that, when it takes into account the tool length offset, when you're just jogging around, is that you've got this immediate DRO system, a digital readout, like you would on your manual mill and lathe. So when you come and just start handle cranking, if you got the E-wheels on a TL, it's gonna be where you can just call up your tool in the turret, jog up to the face of the part, set your work offset if it's already done, and everything's just gonna match, just like a DRO on a manual machine, without having to call up your tool and work offsets. Same thing on the mills, you bring a tool into the spindle, and it's gonna automatically call up your tool length offset automatically. So all this is coming together. We've been using it at the shop for a long time, but it's going through testing. So we'll see more and more of that.
Yeah, cool. Well, we have another question. This is pretty similar, I think, really. Krager asked, will the Haas 5-axis machine support vector programming instead of rotary? And that's kind of all in that same
It's kind of the same thing.
game plan, right?
It's a weird kind of thing. So it depends on which kind of machine. Honestly, we've got tool center point control for full simultaneous 5-axis. We've got dynamic work offsets, G254, on a machine like this 5-axis machine. But again, on this type of machine, you don't need those type of working planes, those type of vector programming, because the head of the spindle is always facing along the Z-axis. It's never off, angle from the Z-axis. So you tilt this thing to B30, whatever, and it's always going to work. You call up your G254, and it's just going to work. So on this type of machine, you don't really need that. And we've already got tool center point control. We've already got dynamic work offsets. On a tilted head machine, like we were saying before, you need something else because everything gets wonky at those angles. And that's where we've given you those tilted work planes with the G268. And so it's a very specific way of programming that, but we've got all those bases covered right now, depending on the machine that you've got. So we're feeling pretty confident that what we have right now can machine any part you need, whether it's on a mill like a UMC, or whether it's a tilted head, like a knuckle machine, a head machine.
Very good. Okay, so we have, switching back to Haas tooling, we have several questions about metric tools. Harindu Gamlath and Rempat 1994. Will Haas tooling be in metric? I took a look at it. We can only find imperial. And the answer is yes, we are working on that. I don't have a firm time frame for when that's going to happen, but that is in process right now. And obviously, if we're going to be selling tools in Europe shortly, we better have some metric tooling to sell, or we're not going to be selling very many tools.
Yeah, exactly.
So the answer is yes, very much in the process of working on that. Then another big one from the last session, where we had just released the video with the review of the TM0 with Brian and Bob talking about it. So there are a lot of questions about when the TM0 was going to be released, and we were talking about at that point about probably October maybe. Right now, the plan is to release the TM0 on the 1st of July, and that will, with a plans to start shipping that, I think around October is what I had written down here. Yes, September, October time frame for shipping those machines. So for all of you that are waiting patiently or impatiently for the TM0, that's the time frame we're looking at. And the other TM models updates are going to follow that, probably right behind that, the release of the TM0. All right, that's enough about the TMs. Kind of just came to an end there. Let's see. This is one I'll answer myself. John Harris asked, do you know when you will be hiring for the Henderson campus?
Oh, what a great question.
Yeah, I live in Vegas, and I'm so excited to see you guys there. So we're certainly not ready to start hiring there yet. Right now, we're still working on the groundwork and putting in utilities and all that sort of stuff. It's quite a large piece of land that we've got over there. Right now, from what I hear, the plans are for the building to be in the realm of 2 million square feet under roof, which is double what we have right now here in Oxnard. So it's definitely going to be a big building or buildings, but no plans yet to start hiring.
Yeah.
That'll be at least a
Expanded
year.
opportunities.
Yeah, we'll probably, I think the plan is to about early 2022 to start the building. That's the current plan anyway.
As an expansion, sure. Different product lines.
So let's see. Interesting. Joshua Ward asks, do you have gang tooling for SL lathes? I wanted to center drill and tap on one tool instead of turret turning.
I know. So there's a plenty of things that can be done with gang tooling. I've seen some really cool gang tools online for a bunch of different machines that people are making, and we do not sell gang tooling right now for the SLs or the STs currently. So there's some aftermarket people. We can look online and see what's out there. You can also make your own to some extent, and it's a really useful and powerful tool. Something that they're looking at constantly. I know the products guys are getting that question a lot, looking at more gang tooling, because you can really take advantage of it. So we've got twin boring bar holders and this kind of thing, which will hold two tools, but not true gang tooling. Like you'd see, like even our CL though, our live tooling has gang tooling built in for those couple tools. But we don't sell gang tooling holders, but there sure are a whole lot of aftermarket people out there that are providing stuff like that, but it would just require a web search.
This is also another question from last month's live event. Vision Forge asked, will the TM0P work with pallet changers or robots?
That'll work.
Yes, if you're willing to do a little bit of work, probably is the answer, maybe?
Yeah, anything's possible, but you're on your own for that. So we've sold, in the past, we had robot-ready interface and this type of thing. And what defined those machines was first and foremost an auto door. Does the machine have an auto door? If it's got an auto door, everything after that becomes simple. If it doesn't have an auto door, then there's no safe way to open and close things. Now we've got universal robots, cobots, that type of thing, which can open and close the door, physically grab the door and open it and close it without a cage. We're running systems like that all over the place. We've got regular robots, which are encased in cages, safety cages, which can open and close a door. Beyond that, if your machine doesn't have an auto door, there's all kinds of cell-safe signals and heartbeats that we're waiting for from the machine to make sure that it's a safe environment. And all those are kind of tied in with the auto door option, which is why we don't support automation if you don't have the auto door. So we don't do it. If you don't have an auto door, you're not going to run automation with us necessarily, unless it's some type of cobot situation or you've built your own cell. But believe me, your HFOs, a lot of the HFOs out there have gotten really good at that automation. They'll provide turnkey systems for you along those lines. And you can always create your own M-code relays that open and close things in the back of the machine. But once you've crossed that line and you're playing with door interlocks and that kind of stuff, it's your machine. It's on you. We only work with complete systems, and that starts with auto doors.
Right. Another question from last time. Quattro asks, is there a way that I can probe more than one hole in a part and see both values in the macros?
Sure.
And the trick, there's like a little bit of a trick to it, right?
Yeah. So there's this. I don't remember the code. So if you go to the Haas website and you go to haascnc.com, you can search down there on the top thing for the Renishaw Inspection Plus manual, and then you get all this information in there. So one way to find out the angle between two hole locations is to use this P9834, or is it 9843? That cycle where it'll probe one thing, it'll remember it, probe another thing, it'll do some math calculation in between, and it'll give you the angle between two holes or different stuff like that. Generally speaking though, once you've gone down that road, you're going to write your own macro. So our XYZ is stored in like macro variable pound 187, 188, 189, and you can see that in the Inspection Plus manual. And if you're on next gen control, that'll be macro variable 10,000, 188, 10,000, 189, right in there, that range. And so if I was probing a bore, I might probe a bore and then say, okay, macro variable 101, pound 101 equals pound 188. And then I'm going to store that probed information into macro variable 101. So my first hole, that information is now going to be in 101. Then I go to a second hole, I probe it again, and then as soon as I'm done with that cycle, blocking look ahead, we made videos on that, you can Google them, we'll say pound 102 equals pound 188. So we're going to store that probed information from that second probed hole into variable 102. So So after each probing cycle, we take our probed information and then we store it someplace more permanent. Because the probing routines wipe out all those variables and they overwrite them with each and every probe hit. And so after each probe, you have to write it someplace, put it someplace in another more permanent macro variable so you can do your own calculations with it. So that's the easiest way, is just to take care of it yourself.
Maybe we, looks like we're getting close to our end time. Maybe we wrap this up with one more question about grinding. This is an interesting one. I'm not exactly sure what, anyway, the question from Intubun Gamer is it possible to do grinding on a UMC or maybe even machine carbide with special end mills? Not exactly sure what this application is, but...
Yeah, so again, it's that same type of thing. You got to be really careful. We've got people, oh my goodness, we've got some terrible, awful, horrible photographs of machines where people will buy machines and use them how we say not to use them. They run these machines with water for coolant for their grinding operations. So there's no oil in there. There's nothing to lubricate the way covers and this kind of stuff. And so they're running these things with water and they're running grinding on it. And they'll buy these machines, they'll run it on glass. Silicon carbide's great for any hard material, even grinding on glass. And so they'll be grinding on glass and carbide and weird stuff all the time, and they have to buy special bellows to protect their ball screws. And it's really hard on the machines. And we have a lot of customers that do that, and they get good at it, and they get good at their own maintenance. But that is totally
it's the same as the robot
base.
on the TM0,
Yeah.
right? It's
those
very
type
much.
of abrasives are horrible for CNC machines, just awful. So yeah, absolutely don't do it. But at the same time, we got lots of people who are doing that all the time and making it work, but they've made it work, and they've got incredible maintenance schedules to keep things going. Or they just replace the machine every so often, every 5-6 years for their application. So that's one way to do it. So no, you don't want to be grinding inside the machine.
Unless you've made preparations.
Unless you
for
do it, and there's people that do that kind of grinding all the time, and then it's a great use of the machine. They're used to the machine. It's a great value for them.
Right. Well, maybe let's wrap it up. Is there anything more you'd like to say about the grinding paraphernalia you have on your deburring paraphernalia?
So you know what's funny? So I'm looking here at my old wheels, and they're all chewed up. You know what I'd like from you guys, if you could, leave a comment. Let me know how you're cleaning your stones, your bench stones. How are you cleaning these things? So I'm not an expert on grinding. I love CNC mills. I love CNC lathes, and I use stones, grinders, this type of thing as much as I need to in my CNC work. But I'm not a grinder. When I walk through the Haas factory and I see our gear hobs in our grinding area, I'm blown away. It's a very unique beast, and so I'm not as confident as I am on these machines as I am with, let's say, grinding wheels. These I used every day, and these guys I use every day. But actual grinding wheels, not my thing. But cleaning these things off, there's all kinds of weird homebrew methods to clean these. You can buy flattening stones, which are kind of like stones. They're just aluminum oxide or silicon carbide stones with grooves in them. They look like lapping plates. And you can run your stones across them and they'll clean them out with the debris. And those are a good way. What I used to do is I'd go by the grinding room and where they're actually doing quite a bit of grinding, and I would grab a handful of the grinding dust from those wheels. And we had an old cast iron table that we used for different things. And I would put that dust, all that abrasive dust on the table, grab my wheel, we would run it over the iron, and I would clean my stones that way. Some people dip them in kerosene, all kinds of crazy
reverse
things.
lapping or something.
Yeah, you can take two
something.
stones and rub them together and clean them up. And so it's like reverse lapping. Yeah,
It's like you said, like when you use accidentally or whatever, use aluminum on a heavy grinding wheel and you load it up completely.
Oh my gosh.
Then you're searching for something else to
that guy.
unload it, like another chunk of steel or something. Who knows if that's the right way.
Yeah, so what are you going to do? You can find another chunk of wheel. You guys, you have those big, the rough, coarse grinding wheels, the bench grinding wheels. So if you ever seen those Star, the Star, what do they call it? Dressers. They're wheel dressers. And so you load that sucker up, and then you pull out that Star wheel. It's got the little teeth on it. It looks like like a pastry tool. And you walk up to the grinder, you go, and it gets rid of all that aluminum that the last guy put in there. And you have to clean off the grinding wheel because so-and-so, loaded up with aluminum.
It was me that loaded it up.
Yeah. Those things are terrible. Those Star wheel dressers are just horrible. They're fine for fabrication work where you're just roughing out some material. But now that you're never going to sharpen a drill bit by hand on that wheel again, because those Star wheel dressers are so rough. You can buy diamond wheel dressers that look like tiny, like little hammers, but they've got diamond material on them. You can square up your wheels with those and redress the wheels there. So there's all different kinds of wheel dressers out there that are pretty efficient. But yeah, anyhow, so that's if you have anything at all, any secret tricks in your bag of how to clean off your stones, let us know. Put it in the comments. And again, if you've got a great source for gang live tooling for your lathes, SLST, what have you.
Yeah, drop it in the comments by all means.
We'd love to see it.
And if there's something we haven't answered in the questions and comments here, by all means, we'll post this video and the original one as well up on YouTube, and you can ask those questions there, and we'll try to get around to answering them.
And I'll say it again. So if you guys aren't sure which tools to buy, if you're not sure what you're going to buy, so generally speaking, if you're going to buy these guys, these deburr wheels, if it was
what's
me,
the best one to start with?
Honestly, I'm going to buy an aluminum oxide wheel. This aluminum oxide, it's hardness 8. It's a medium grade. This is kind of rough. I'm going to buy silicon carbide. I'm going to probably buy the 8 as well. This is a softer one. You can always go a little bit harder with it, but if you're going to go with hard materials, that's it. So I would get one of each of those two, and you'll test it on different materials and hardnesses. You'll see the difference. You'll see how quick or not quick they wear out on your particular parts. And so if you're doing any type of production, you need to do that because you're going to see a difference. Can you get away with an aluminum oxide general wheel? Do you have to go with the silicon carbide for that sharpness and clean cutting? On your machines, generally speaking, some type of aluminum oxide stone, bench stone for cleaning your tables. It's what everyone else uses. I use a silicon carbide, but I've gotten used to that feel. I don't know. I don't know if I'd suggest this. It's what I buy, but you have to be careful with it. Use the fine side. Don't get too aggressive. It's good for knocking. But an India stone, a Norton brand India stone is what they're really called. Otherwise, it's an aluminum oxide stone. It's perfect, a fine stone for all the bench work that we're doing. And they come in like the sticks. This is a 1/2-inch stick tool. They have a 1/2-inch triangle tool. These are perfect for reaching in there. They're fine enough where you're not going to damage your fixtures, and they're rough enough where it's actually going to get the burrs off. So if you've got a fixture and you need to clean off some pads for something, these fine aluminum oxide stones are perfect. So every shop should have a few boxes of these guys around for super fine work, for dressing, some high-speed tools by hand, that type of stuff, for cleaning up, some very specific tooling for that last little bit. Arkansas stones are amazing. But again, you're not going to be removing material with these guys. It's just for that final polish. So there's a lot of stuff out there. Check it out. Oh, I'll mention again, I don't know why I was thinking about this. We talked about it before we went on. Silicon carbide, aluminum oxide, you're going to hear these terms for the rest of your machining lives, so get used to it, especially with like cut-off wheels, grinding wheels, deburr wheels, bench stones. And
yeah, they're in every level of aggressiveness you want to do. Yeah, from cutting off a piece of steel tubing to the super fine work that you're doing there. We
were talking about how like the gun industry, these type of guys, they were actually rolling their grips in silicon carbide to give these super aggressive grips that will work even if your hands are sweaty and oily. So you're going to see these materials a lot, especially
they're not going anywhere.
Yeah. So yeah, it was a great topic.
I think that about wraps it up. Thank you so much, everyone, for joining us and for coming back to the second stream after we had our little shutdown there. If you missed some part of it, if you logged off and you didn't make it back on, I think what we're going to do is take these two videos, combine them together, and repost them. So check the channel, and you can see this video in its entirety. And even there on that video, once we post it, comment your questions. We look at those comments and can reply, or the group of viewers here can reply with different sources where they can help each other out. That's it. Thanks for watching. Thank you so much, guys.